So let's say you are told to find or draw the skeletal formula for this following organic compounds. So the first thing that you must know is how to draw a structural formula for each and every organic compound. So in this case, firstly you are given the butane. For butane, you know that it has 4 carbon atoms. So after you have drawn your structural formula for butane, you have to draw a skeletal formula. So this structure here will lead you to draw a skeletal formula. So you have to know that this part over here represent this carbon or the first carbon. So and that part over there shows the second carbon atom. That will be third, that will be fourth, and lastly we're gonna have butane, just like that. So that's how you draw a line structure or skeletal structure for butane. Now let's look at the second part, which is 2-methyl-hexane. So here it tells you that you have a branch on the second carbon atom where there are 6 carbon atoms in a straight chain or in a longest branch. So we're gonna have 1 2 3 4 5 6. So there will be a branch which is only 1. There will be hydrogen atoms surrounding. So after you've drawn the structural formula, you can do or draw the branch, I mean the skeletal formula. So as you learned, firstly this part will be the first carbon atom. 2 3 4 5 6, and then you have it just like that. So how can we draw our branch in some cases? So the branch might be drawn just like this. So that's how you draw the skeletal formula or the line structure for 2-methyl-hexane. Now let's look at the third question. So we have 2 branches in this case, and then they are all in carbon number 2. So the longest chain will be with 5 carbon atoms. So it's gonna be 1 2 3 4 5, and then connected with single bonds. So the branch will be over here, just like that. So after you've drawn your structural formula, you have to draw the skeletal formula. So here it will be the first carbon atom, second, third, fourth, fifth. Now let's look at how can we connect our branches. So our branches are on carbon number 2. So you may draw a line over there, just like that, or you can even draw it on this carbon atom over here. It doesn't really matter. So let's do the last question. For a cycloalkane, you know that it doesn't have any multiple bonds, so it's gonna be something like this. And then lastly, as you can see, you have a branch which is a methyl group. You can put it the branch, or I can say you can put the branch over here or even over here, it doesn't really matter. So that's how you solve it for cycloalkane. It's very simple.